everyone. We're going to be doing some streaming today on Haskell. It's been like 2 weeks. I feel terrible that I've let it go on so long. But, I think I've been having a hard time finding my way. Don't have like a standard sort of job, so my days are very well, my days are very ad hoc. Um, so I don't have a schedule. Oh my God. So I've just been kind of trying to find motivation to do things. And when I get out of a habit of doing something learning Haskell, it's hard to get back. But we're going to do it. Do I have anything else to say? I don't have that much time today. I have an hour or so because I am going to a Gleam meetup tonight. Um, and I have to get ready for that. I'm not dressed or anything. So, yeah, have about an hour. Mostly I want to review because I have to make sure that, you know, that I've haven't that I remember what we were doing before with Haskell, and hopefully we can start streaming more regularly from now on. What else is going on? I think it was after the last stream. I set up an Elixir meetup in Paris, and that went well. Double the people came this time than the last time I set one up. So I'm happy about that. We announced that I'm in the program committee for Goatmeyer, which is a conference which is combined like NervesConf EU and also an Elixir conference, so that'll be fun. That happens, I think, in September or October. It's like towards the end of the, towards that time of the year. Probably later. I think like ElixirConf USA is in September and then Goatmeyer's probably in October. That would make sense. It's a little weird if they were both the same month. All right, I need to get chat up here so I can see. All right, there we go. So that's it. Let's figure out where we were. Let's get the browser up. We are learning from Learn You a Haskell for Great Good, which is a free book online. All right, let me just resize some of the stuff. Da, 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 da. And this font is too small, right? Maybe like this. All right, I think that's good. So we've been reading this book and we got through, I think we're doing syntax. So let's just take a quick look at syntax again and make sure we remember how to do things. Maybe we'll just kind of try to do some of these exercises. What is this doing? It's basically looks like it's saying, hey, oh, it's pattern matching on the function. So if you pass it 7, it's going to say it's lucky 7. Otherwise, it does whatever, right? So here, let me make a review dot HS. It's called HS, right? Yeah. And in here, we want to make a function lucky 7. Jesus, what's the syntax for this? And I think here we just tell it what it's getting, like an integer, and it's going to return a string. God, this does not feel right at all. And then we define the function lucky 7. It's going to take in an x. Now we define it. But we got a pattern match, right? So lucky 7. God, do we just do 7 here? And then anything else, we say, all right, I'm pretty sure that's not going to work. And then what is it? GHCI? Oh, it loaded. Oh, wow. All right. It fucking worked. Oh, right. That's not how you do it. It's not like that. Did export pager? Oh, editor. What am I doing? Okay, so I can't remember how you put the number in there, but we'll worry about that. Okay, so what they did is they didn't make it just an int. They made it work with any integral, which includes big numbers. So this means we're constraining a to be an integral. It takes in an a and it returns a string. So a can be either an integer or a big integer. All right, so say me. This is basically the same thing. I'm not going to copy this. And then we can write factorial recursively. So that's a class type. And then we say we take in an a and we return an a, right? And then if my factorial, you pass it in 0, then you return 1, right? And then my factorial, any other number, is equal to x times my factorial x minus 1. I think that should be right. reloaded. So why is this not typing anything? Hello? Don't know what that was about. It's like my computer's super slow. I don't know why that is. Yep. Um, I see. This is when it fails. Pattern matching. Adding vectors. All right, so we're going to add two vectors together. And a vector is a tuple. Trying to charge my phone so that when I leave, I will not be I will not end up at the Gleam meetup with no battery on my phone. I hate that. Add vectors, and we'll only add two vectors. So, I guess we have integrals again. And we take in a vector a comma a and another vector a comma a, basically two integrals, and we return a comma a. Sure sounds weird, right? I'm talking to like a guy friend from elementary school, primary school days. And it's just so funny because his life is so different than mine. He's saying that, his life has changed so much. And like, we're trying to find ways to find similarities, but it's really hard because, like, his life, his like social life, what he does is just like completely different. Um, so it's interesting. It's interesting to see how much we change. All right, so we take in, we can pattern match here. Well, I guess we don't have to, right? We take two vectors, vector x, vector y, and then is it called first x, and then we turn first x plus first y, comma, second x plus second y. Is that right? God, is this language server working? Like, I'm not getting any like errors. Add vectors. Well, that worked. Now, I think instead of this, what happened? Hello? Oh, it's not this. This is the yank register. Okay. Well, it's actually not a huge win here. Oh, it's giving me a suggestion. So why don't I just do, can't I do x1, x2, y1, y2 and pattern match like this? Does this not work? Yeah, that still works. I'm pretty sure this is like using this code, right? Yeah, it's using the code. Like, maybe it's just magic. He's talking about having a scorecard of his own development. Like, it's such a different way of even thinking, you know? Anyway, where are we? Yeah, add vectors. Oh, they did it afterwards. Okay, first and second. What about triples? They make triples. I don't think we need to do that. What is this doing? Ah, you're using list comprehensions to match and then oh, it's just adding them together and making a number. So it's 4, 7, 6, so forth, right? The thing to note that I always forget is that in a list comprehension, if a pattern match fails, it will just skip over it. So it's kind of like dangerous in that way. All right, so what are they making? Our own head? Let's make our own head. So with head, we really don't care what type it is. It's basically anything that is a list. So we're taking an input of a list, and we're not going to return a list. We're going to return whatever is inside the list. And remember, in Haskell, everything has to be homogeneous, so they'll all be one type. So we're going to pattern match here. How does it look? I think it's like, no, it's like this. Let me play with this for a sec. What is it like? Is this how it goes? No, it's like, no, fuck, how did we do this? Ah, here it is. It's the colon. All right. Yeah. Okay. We don't care what the rest is. I think we need to put this in parentheses. And here we're going to just return the head of the list. Yep. So this is basically pattern matching the list. It's breaking down the first element and the rest of the list with the colon because, we use the colon to construct a list and put the first something as the first element of the list. And we put underscore here because we don't really care what that is. Like this could have been y, right? And this would work, but we're never using y, so why are we pattern matching it? All right. This is kind of a nice example of how you can deconstruct different sized lists using the chaining the colon operator here. All right, so we need to make our own length function. Let's try that. So this is going to take in a list just like before, and it's going to return an integer, right? I guess we can even say number to make it like the most wide so that it can be used with other functions. Hey, there's people here. Why don't you say hi? How are you guys? Unless you're bots. Are you guys been here before? Are you learning Haskell? Just here for a second. All right, so what do we have here? If we pass in my length, the empty list, here's our base case, right? Then the length is 0. Otherwise, we're going to break it up into a head and the rest, right? Oops, that's not how it works. And the rest, the R is a list here, right? So we took one element out, so we're going to do 1 plus my length R, because R should be one element smaller than what we started with, right? So this should work. We're always making it smaller. We'll eventually get to an empty list. Oops. Num. Expecting one more argument to num. Oh, is num a type class? It probably is. My length. Empty list is 0. My length 1, 2, 3 should be 3. All right, so that worked. We're getting through this pretty well. I guess we remembered some stuff, right? Is that how they did it? Oh, wait, that's not it. Tell length, yeah. Yeah, so they made the type class here, which is I was going to do, but I got lazy. And then we basically say we're going to return a number. All right. Oh yeah, so you can call it on a string also, because a string is just a list of characters. That's 5. Empty string should be 0. What's this doing? Sum is taking a list of numbers and summing them together. You know, I think we can do this. Like, I'm pretty confident we don't need to do this because it's pretty much the same thing we did with head, except we're going to keep track of adding, not head, length. All right, capital. What is this doing? Capital is the first letter of is X. All right, so it's just, why is it called capital? Doesn't make any sense, right? It's basically first letter. So odd. I'm trying to understand what this example is. I mean, obviously it's trying to teach you this at sign thing, but it just doesn't make any sense. So I'll call it first letter. And it takes in a string. And it's going to return a string. And what does it do? All, we can call it whatever, right? Full, at, and then we're going to break up the pattern matching to head and rest. And we don't care about rest. First letter of full is, and then here we need to put the H in a list because concatenation only works with lists and H is a character. So we put it inside of a list. Strings are lists. That should be correct. Oh, hello. Yeah, it's weird to call it capital, right? It's so strange. First letter foobar. First letter of foobar is F. Okay, so we figured that out. Guards, guards. We learned some guards for functions. They just basically mean only call this clause if you meet this only if you meet this condition. So you have parameters mass volume, but you only call it this one if mass divided by volume is less than 1.2. Here's our max function. That one, like this one kind of seems silly to actually write. So let's write our max function. How you doing, lazy schemer? So the ordered type class means that it has the equality and, inequality less than, greater than, equal to. So we're going to say that it needs to be ordered. And we'll take an A as one parameter and another parameter. Oh, hey there, Ice Cold Witch. And we're going to return one of them. right? We're going to return one or the other. And so we write x, y, and then we have our parameters here. There's something really funny, like you need to put this one tab width in, I think. Is that right? It's something weird like this. Um, I think it's like you gotta tab it. Or maybe it's like 4 spaces? 1, 2, 3, 4. Maybe it tells you up here. Usually they're intended a bit to the right. Oh, maybe it doesn't matter. All right, well, I'll just indent it. So if x is equal to y, no, we can just do it with 1, right? If it's greater than y, then I think we do equals, and then we say x. And what was the keyword? Otherwise? So how did we do? My max looks correct. It can be 2 spaces over 4 spaces, whatever you like. Did I tell you I had a Gleam meet? I have a Gleam meetup tonight. I'm gonna go there, and I'll be the only person who doesn't use Gleam. Yeah, I organized an Elixir meetup, and and twice the number of people came than the first time I organized one. This is my second Elixir meetup, and it went really, really well. I think the third one I'm gonna do, we're gonna have presentations, so that'll be fun. I wonder if I can even stream the presentation. Maybe there's a way to do it in person but also stream it. That would be really cool. And I started working on my talk for ElixirConf. That's at the end of April. I'm building a game server. I just started, so I just have the scaffolding so far, like starting up a gen server, having, some of the classes, but none of the fun stuff, nothing that feels like a game yet. And so a lot of work to do before end of April, and I'll probably stream a bunch of it once it gets a little bit further on. So what is this doing? The when, where? Ah, right. So you don't have to calculate it every time. Because here we're trying to figure out the density, so we have to write mass divided by volume, and here we just write it. initials. Oh, I hated this one for some reason. Why is that? You pass in a first name and last name and it just like puts the initials out. Initials. It takes in a string, and returns a string. So we have two strings, and we have a where. So I'm deconstructing X, which is the first name, the first initial. And then I deconstruct last initial from Y. And then I can use these, I assume. So this is just a character. Something like this, I think, is what it should be. First name, full first name, last name, and then first initial, last initial. Is that what they were trying to do? Yeah, it looks like it. It's basically like let in block, but you can put it after your main body expression. Usually we like to use where instead of let for pure functions and let inside do blocks. Did we play with let already? Ah, that's right after. Very similar to bindings are let bindings, so we just put it in the beginning. I will copy this. I don't know that we did this last time, did we? We must have. We must have done this. But I don't really remember this. That's what's weird. So we have a type class real float, and we take in the dimensions of the cylinder. Take the radius and the height. So cylinder, radius, height. And now, okay, so we're trying to figure out the area. Let side area is equal to 2 times pi. Oh yeah, I remember it doing this now. And we have top area equals pi times r squared 2. And then you use in. I see. And this is what we're going to return. Let bindings are expression themselves. Where bindings are just syntactic constructs. Which means you can return you can like assign something to the result of a let binding. Yeah. So this will return 10, and you get 42. All right, I'll pass this for now. Now, this one I want to look at. Calc densities. You take in a list of tuples, which is the mass and the volume, and you return a list of densities. So here are, you pass in that list of tuples, and I see here's the x's, here's the condition, let density. So I see. So now you can use it here. Ah, so what this is doing is it's not returning the function. This density is bound to this value. So this is just like actually inserting that calculated value into the list. Let's do that. All right. Calculate densities. And we can also use real float here. And it's going to take in a list of tuples, which is mass and mass and volume, right? And it's going to return a list of densities, and they're all real floats. So now we're going to here pass in our list. So x's is our list, and here's our list comprehension. And we're going to deconstruct the tuple to mass volume from x's, And then as instead of our predicate, we're going to bind in a let density is equal to mass divided by volume. And then I can use that over here, right? So 10 divided by 2 is 5. 9 divided by 3 is 3. So it looked like that worked. Is that how they wrote it? Yeah. So we could make our function return only the densities that will float in air. I see. That's bigger. That's less than 1.2. Do I just do density is less than 1.2? Yeah, so it only included 1 because the others are bigger than 1.2. We can't use density in. Right, they're saying we can't use density in here, right, because this part gets evaluated before we get to the let. That makes sense. If you think about it, we're grabbing stuff out of the list, right, to build this list comprehension. The predicate part comes afterwards. You need to know what you're dealing with as the element. We didn't have the in part because the visibility of the names is already predefined there. However, we could use a let in binding in a predicate, and the names defined would only be visible to that predicate. Got it, got it. So when you use let like this, you see this, right? Yeah. This is then visible outside of this let. But here, XYZ, this becomes let this in here. And now boot is no longer in scope. So this means we're defining this function within this let in scope, and then we evaluate this using the function that we just made available within scope, and then we return it as the evaluated expression, but then boot disappears. Why not use them all the time instead of where bindings, you ask? Well, since let bindings are expressions and are fairly local in their scope, they can't be used across guards. Some people prefer where bindings because the names come after the function they're being used in. That way the function body is closer to its name and type declaration and to some that's more readable. So it's just saying if it's in the end, and then you can use it wherever, then it's like maybe more readable sometimes. But let bindings, they're going to have local scope. Oh my God, I'm almost out of time. I thought, oh, case. Maybe we didn't get this far last time. All right, let's look at case real quick. Then we'll stop. We'll stop for today and we'll be able to continue more next time. Gotta keep going. Gotta learn Haskell. All right. Many imperative languages, C, C++, Java, etc., Rust, Go, have case syntax, and if you've ever programmed in them, you probably know what it's about. It's about taking a variable and then executing blocks of code for specific values of that variable, and then maybe including a catch-all block of code in case that variable has some value for which we didn't set up a case. Haskell takes that concept and one-ups it. It, like the name implies, case expressions are well expressions, much like if-else expressions and let bindings. Not only can we evaluate expressions based on the possible cases of the value of variable, we can also do pattern matching. Taking a variable, pattern matching it, evaluating pieces of code based on its value. Where have we heard this before? Oh yeah, pattern matching on parameters in function definitions. Remember the whole function clause thing? Well, that's actually just syntactic sugar for case expressions. These two pieces of code do the same thing, are interchangeable. So here we have a function clause where one is for the empty list, and here is one that has a list. And here is one where it's just one function clause, and it has a case inside of it, and it says case of empty list, do this, and I guess otherwise do that. It's like kind of indented pretty far. It probably looks better if I had a wider screen because this stuff here would continue. So you can see it's case expression of pattern result. All right, let's try to write this. We're going to look if it's an empty list, a single element list, or a longer list. Describe list. We're going to take in a list of elements and we're going to return a string. And we're going to use a case expression. So here we take in some x's. Case expression. So empty list. No, oh no, it's the thing we're evaluating. X's of pattern result. Oh my God, seriously? 1x, 1 item. Well, we'll just... And then anything else, I assume I can do this. Multiple. Is that it? I think so. describe list, empty, one item, multiple. What is this? Is this different than mine? Oh, they just have the list is. Whatever, right? It doesn't matter too much. Because pattern matching in function definition is syntactic sugar to case expressions, we could have also defined this like so. Oh, I see. They're just defining the function here though, right? Oh, that's so cool. I see. So you see, like this whole thing could have been a case expression, right? And it returns something. But this literally is a case expression. This turns into something you could resolve, which is basically these function clauses. Like case empty, empty, case something this, just like we wrote here. So we kind of turn it into this. Well, that's really cool. And it's exactly time for me to start getting ready for my Gleam meetup. If you don't know about Gleam, you should check out the language. It's really cool. I really like the people involved with Gleam. The core team are really nice. The language itself looks really easy to use, but I just haven't had a chance to really use it for anything yet. Can only learn one thing at a time, and right now I'm kind of like gotta learn Haskell. So we'll maybe learn Gleam afterwards. Thanks for hanging out. The next time we do Haskell, we will be looking at recursion. Did we already do this? God, so we're just reviewing stuff that maybe we did before. I don't know. I feel like maybe we did recursion already. It looks very familiar. Maybe not. You pass in how many times you want it to be replicated. And if it's 0, you return a list. Otherwise, you are building a list where you take X, the second item. Oh no, this is not a tuple. This is just two type classes. I see, it has to be a number and ordered so that you can compare it to 0. Is that right? I thought number already would include that. So you take in the number of times you want to replicate it, then you take in the item you want to replicate, and then you return a list of that item. So if it's 0, then you just give the empty list. Otherwise, you pop it into the list, the item, and then you recursively call replicate, but this time with n minus 1, so you eventually get to 0. No, we definitely didn't do this. So that'll be next time. All right, thanks everyone. See you later.